Hello, welcome back to the stream. I'm Junchan and we're doing some Purescript and some graph Comonads today again for the 8th episode. We've been doing Comonads for a long time now. But yeah, I just had to change my Steam key because my Twitch key, since apparently there's been a data leak and they reset all the keys. But it seems to be working, so let's just get right down to it. Okay. So, what do we have? We were working on the Purescript Alga port from the Haskell algebraic graph library, or Alga as algebraic graphs. And we've done a bunch, and we were working on hasVertex, and then we have a bunch more to do. So let's just get down to it. So actually, we're not working on hasVertex, we're working on vertex set. Vertex set. And let's do our little housekeeping. We are on the 7th. I think I might have not done that last time I streamed, but that's okay. And here we go. So yeah, we were trying to find out whether we could express vertex set in terms of fold G and yielding a non-empty set. And I was hoping that by using append here, I could use the semigroup instance of non-empty set and basically append underneath non-empty, and append being set union, do the union, and I suppose we should look at what vertex set looks like in interesting. Look at this. Vertex set for in the Haskell algebra non-empty actually is t.vertex set. What is t.vertex set? It's algebra graph to graph. Oh, okay. So it's fold G, empty, singleton, set union. But hold on. How is that going to work? It's returning. I see. So it's just using the vertex set from the regular vertex set. Giving back a set. Using probably the two vertex instance to get a... well, no, of course. The thing is that it's not using a non-empty set. So we're trying to modify the API slightly here so that it's more regular and that we give up also using the non-empty data type from Purescript, which takes a higher order data type here, or parameterized data type set from type to type, and the type, and turns a set A into something that has an A const to a set A. So we're sure that there's an A in it. That's the definition of non-empty. Okay, so the fact that we're trying to do something new means that we can't rely on what's there. So our fold G is going to take a vertex and it's going to transform it into Vx. So if we only have an X, then singleton, we're hoping, should give us a non-empty set. But apparently that's not the case. So why wouldn't it be the case? Because we're taking a graph A as input here. So yeah, if our graph A has a vertex, then we return just singleton empty set. But singleton might not be where we want to use for right. We're going to need something. So I'm trying to use singleton from set, but we would need to pass it the x, but that should work. Why do you need an non-empty needs plus on f? So hold on, that means that we can't do non-empty set actually? Or does it just mean that we can't do singleton? It might mean that we can't do singleton. Non-empty, where are you? You are... That's not the non-empty we're looking for. That's the one. And singleton takes a plus. Oh, I see. But it could just take monoid too, and set has a monoid instance, right? Or we just construct it manually, which is probably also fine. So we do something like blah empty, and then we use the monoid instance for set. That work? Well, it seems like it works, but let's see whether whether set really has the monoid instance. It does. So empty is empty. So there is an empty. There's just empty for set as well. So we could have done empty, but empty I think is fine. And so apparently now append is not okay. Why not? Because semigroup. Oh, right. Because we are using a variation on the non-empty data type that has a PR now and whatnot, that added the semigroup instance, but also requires f to be an applicative. But then you tell me set is not an applicative. That's a little bit sad, but it might be the case. So how is set applicative instance? Almost correct. So there is an instance. It satisfies all the applicative laws. Is that the one we want? Pure equal LMX empty. Okay, hold on. Oh, set empty lm and set. So that might not be the set data type we're working with right now, but let's try and understand it like so. So empty gives you a set A, lm takes an A and a set A and gives you a set A. Okay, so lmxmt is the set with just a x in it, so that seems to work. I understand that. And then the map, the app is such that if you have, so the app, yeah, takes a set of functions and applies it to a set of A's. And so if we don't have if we have an empty set of functions, then we have an empty set. If we have an empty set of A's, we have an empty set. If fx is an element, yeah, okay. So it's like it's an inductive definition so that we can unroll things here, but it makes me think that it's not so It's not so far-fetched to have an applicative instance for the regular set, but we don't have it. Wonder why. So what does this do? It's okay. Now I'm a little bit wondering why is there? Yeah, there's even not a functor instance. Setting data set requires that the element in ORD, which prevents them from being a functor. And I suppose we have the same restriction here. Elements. I mean, there's an ORD instance there, but it's not here. Let's see, how does this work? I mean, yeah, it's mostly there, right? As soon as you try to insert a thing, then it needs to be in there. And same for here. So unless we define a set that doesn't have ORD, but if we don't have ORD, then we can't. I mean, even if we just had EQ to avoid duplicates, which, by the way, the Stack Overflow thing doesn't have, right? LM is basically just like it's just a list. This is, I think, just. I mean, depends what the implementation of LM is. De facto standard nested list. Ah, right, okay. So it's nested because set nests a set inside another set. One set has a monoid instance. Bit of a rabbit hole here. Not sure how to manage that, but if we go back to our problem here, it means that our non-empty is not gonna, the semi-group instance is not gonna work for us, which is a little bit sad. Really does feel like a like that there is some meaning to an applicative set. It feels like it. That ORD instance isn't it a kind of a just a sort of an accidental constraint there? Okay, definitely not that. Right, reset that, and yeah, package. It is .com, right? .org. It's haskell.org actually. News. What? The set monad applicative set. Set abstract data type and set manipulating function. This function behave exactly as their namesake for the data.set module of the continuous library. In addition, set monad library extends data.set by providing function applicative alternative monad and monad plus. That sounds like what we want. It is not possible to directly implement instances for the aforementioned standard Haskell data type class for the set data types from the continuous library because the key operations map and union are constrained with ORD. Exactly. And the set monad library provides the type class instances by wrapping the constrained set type into a data type that has unconstrained constructors corresponding to monadic combinators. So let's do that. How about that? Data.set.monad. Does this exist in Purescript? I mean, you know, that's definitely a rabbit hole, but that's an interesting one. Purescript set monad. Let's write it like so. Like making a set monad. Constraint kind, so you can make things with class constraints monad, like making a set monad. Ooh, class constraint monad. You can't have a monad with constraints. Yeah, that's right. And we bumped into this earlier too. And you know what? I forgot what it was. We tried. I think it was with the Purescript arrays. We were trying to give a semi-group instance, but non-empty was carrying some other constraint. Wasn't that? Is that what happened? Orphan instance found. No, that's not it. I kind of forgot, but now I remember that we had that same question last time. And yeah, it sounds, is that, yeah, restricted monad. I wonder what it is. Is that like a slice category or something? Like a quotient? Like a way to restrict. Okay, let's see. A package called rmonad, which has some constraints that are instance constraints. Is that like a way to refine constraints somehow? I don't know, but I don't like this API. That's a bit crazy. But with constraint kinds, we can turn constraint num A into a type, which sounds like some kind of reification. You can then have a new monad class which contains this type as a member. The constraint itself. Yeah, I see. Restricted monad. Parameters. You can now make set an instance of monad by having this reified constraint. But we don't have constraint kinds in Purescript, as far as I know. It might be on the way with all of this polykind refactoring thingy. Constraint kind, Purescript. same one. And probably not there then. Constraints. Because it does not support constraint kinds. 2019. Okay. So no, not yet. Okay, just want to then sort out this idea of restricted monads and category delay monad, the restriction category, restricted monads. Generic monad construct for embedded languages, set monad. I hope we can write the set monad, by the way. It's Oleg thing, apparently. Pretty cool. Restricted set monad. Oh. Ah, yeah, set monad as a restricted monad, yes, but not as a monad. Unrestricted but inefficient, and then efficient. Cool. So, okay, let me see whether slice actually comes up with something. Doesn't look like it. And how about quotient? Quotient types. So maybe. But so do we want to go into this rabbit hole? The problem with set monad is that, I mean, it will be a set, so we can just put it in like some internal in Alga. And then we'll be returning this non-empty internal thing that would, in theory, wrap the actual data.set module, or behave the same. It's tempting. It's tempting. It's a little bit far from graph Comonads is the problem, and I could probably implement vertex set using a different data type here than non-empty set. In fact, the original vertex set didn't even try to return non-empty set, just return set. Decisions. Decisions. It gets into Buddhism, apparently. A better Haskell. So many of these paper cuts that I just walked away. So to here. Okay, a classic prelude. It's a big vehicle prelude. I see. Interesting. A friend of mine told me that I heard through a friend that a friend said that most of the Haskell programmer he knows are Buddhists. I didn't know that, but I suppose probably not most. I mean, most of the Haskell programmer he knows, I'm sure that's true, but apparently there are some lingering out there. Okay. Or abiding, maybe. Restricted monads. The set monad. I like the idea of having a set applicative and a set monad, to be honest. I think it's very logical to have. I'm sad that we don't have one. So therefore, let's scratch that itch. Let's do it. No need to shout. So Purescript set monad. Let's just double check that this doesn't exist, because sometimes you search for things and actually they do exist. So not there. And then GitHub, searching GitHub through Google is actually not that easy. And yeah, there is no such thing, it looks like. Okay, so let's try it. I want to make it a Spago project because that's how we do it. And then what? Apparently this doesn't reference the Oleg paper directly, so I don't know whether it's using that technique or not. It says, hold on. The technique is not new. The was inspired by one. Monad verification and the sunroof JavaScript compiler. Okay. So that's, I suppose, is one approach. We could take a look at the code. And it's not very big, so that's nice. And then we could also take a look at the set monad code right there. And it's also not very big. So possibly we could try both. Obviously, I mean, I say obviously, but I think this one doesn't have applicatives, whereas I think we saw this one did. So, I mean, it's not going to be a big thing, but oh, and run transforms it into a regular set. So let's do that. Let's get to it. So screw it with me. Let's make it in the Purescript README style. That's not really how Purescript READMEs look like normally. It's more like this. Purescript set monad. A set data structure with monad, applicative, and functor instances from not that either. Boom. Okay, let's go install set monad. And is it published in Pursuit? It really isn't. So for now, let's comment it out. And when it will be there. Okay. So I think that's set monad. And then we start. We start with data set and monad. and we go. So we start with the data type, data set A, and yeah, I think we can do this in Purescript these days. Let's hope. I'm not even sure, but we shall discover. And we need to import data.set as s. So that's the thing. And no, we can't do that. So that's an early stumbling block. Stumbling block, yes. Yeah, no GADTs in Purescript, but there's a trick to do them. So there's a few tricks to do them. Maybe there's a different one in 0.14. Support GADTs for the compiler. So it's not there yet. Interesting, but meta compared to what we're looking for. So Haskell like GT, yeah. We want GDTs. Okay, so I suppose the other way is to say Purescript GDT and sort by date. Or at least display something from the past months. That's not working. Past year. GATs, GDTs. Okay, entity type. Not Purescript, unfortunately. So how about from okay, give me a date. 20. Well, I mean, it was released. Yeah, it was released pretty early. So nothing really specific to GADTs like recently. I'm a bit surprised. Let's look at the release notes. I thought that Polykind would maybe help with that. It is Polykind, right? That came out in polymorphic kinds. So polymorphic kinds, GADTs, Purescript. How about that? Okay, polykinds. No GDT there. Merging type and kinds. Maybe that's the recap I was looking at, or no? No. That's another one, and maybe help getting pretty kind of the line. GDT in here? No. And how about generally? By latest post. 22 days. quantified constraints, be more likely to be accepted. So GDTs is a big thing, I think. Alterable syntax for GDTs. Hold on, that's in Haskell, I believe. Right? No? Is it ATTA where, blah, the A should scope over. Yeah, I think this is a reflection on Haskell. Yeah, can polymorphism. And this is Richard Heisenberg right there. We imagine these features with less baggage. JC baggage, do you think has been the most constraining to you? The biggest for me is alterable syntax of GDTs. We say F for A proxy A blah, we infer you can K for the type of A. The problem is that there isn't a way to disable that kind generalization, and it sometimes gets in the way. I think that's for kind inference that it's tricky. I think Richard is probably thinking about a ping point from the compiler standpoint, I think, because I don't know that the syntax is really a problem, but maybe it is for more advanced stuff. I don't know. I don't really understand that stuff. Without local context. That's Haskell. I wonder whether this changes things. So the problem and recap. Latest version of Purescript hasn't supported JDTs yet. Recap from what I researched. Yeah. Visible type applications. Running two types. Approximating JDTs in Purescript. Problem with this encoding with equality. I think that's the lightness equality one. I remember trying that. Yeah, that's Gary Burgess, I think. Yeah, it uses this lightness equality trick. And is that the one? Yeah, I think that's the one for here as well. So that makes things pretty pretty verbose, I think. Type equality in a solution. Blah blah blah. I mean, what's different here? Approximating. Oh, so this is a slightly more advanced version using tagless final. Interesting. So there is, but limitations for our research because Haskell hasn't supported predicative polymorphism. That means that we can't specialize an existing data type to hold polymorphic value like this. Fortunately, Purescript supports predicative polymorphism. We don't need to worry about it. Interesting. So that sounds pretty modern. So tagless final, I mean, it's not going to be great for our to provide, I think, a regular interface, because I think we're going to have a wrapper that leaks, I believe, but so our set instance is not going to look like what we want. But I think that's going to be the same for Expert, maybe not. Let's see. Yeah, it might not be the same for with this actually. And the thing is that it can't solve more complicated EDSLs, but maybe it will work with what we want. So, okay, let's try and source this. Okay, so we can do GDT, so therefore we're going to do this. Let's try that. Let's get the original GDT. And let's do it like so. In fact, we can even maybe do it like that and say prim. Well, yeah, I think we can do this maybe the imprecative polymorphism allow us to do this time in Haskell, in Purescript. So let's try. So prim will be this, and return we'll take A to set A, bind to exit A to E. Yeah, and that's fine because we don't, this is really one of the simpler cases. But there's something wrong here, right? No, I think that's right. But then we don't need to use lightness equality, do we? Because the only thing that we have is the val, the equivalent of val, but it's not even that because it goes to an A. So we don't even need to constrain the types further. We just need this imprecative thingy right there. Okay. And then what? Then, well, we don't do eval here. So does this give us what we want? Run. Let's import it as a set. Yeah, where is that? It's not in sets. It's in list, ordered collections. I suppose so. Data list internal has a set, but yeah, that's not the one we want for sure. And Spago build. Another type class ord, yeah. Import prelude should have ord, and then apparently we don't have folder prime, but seems like the types are fine, so that's pretty cool. Folder prime in Haskell. What are you? I need to go here and source and folder prime. It doesn't appear, so let's go to let's make sure that we know which one we're supposed to be importing here. In the Cabal file, set from containers. And folder prime is a strict version of folder, so that's not a problem for us. We are in a strict language. However, apparently our data.set does not have what we need. Why not? Fold has foldable, so we use the things from the foldable instance. Okay, then we don't do, we just use import data.foldable. And what doesn't work here? It's a variable b. Yeah, good point. Oh, trouble appears at the horizon. Yeah, no, that's fine. And what's the dealio there? Rigid type variable prim s. I think we need to apply it. Run takes a set A, returns a S set A. So how does this work exactly? I don't get it. Let's go back here. Prim has a function from set A to set A. I can't seem to be reading the types properly here. Okay, wait, that's not the problem. But Yeah, I mean, that's what I would have thought. Oh, to set A. Yes, of course. That's, I think, is the difference in writing things. That no, hold on. Am I right here? No. Okay, I need to look at the blog post again. Expr val into expr int leads to expr val int together with a int, which is the Leibniz constraint, which we don't need there. So val a should be just fine. Right, it should be fine, but actually that means that we really need to remove the outgoing set, doesn't it? Yeah, but then we'll have trouble because 0, well, 0 is just going to be 0. That's okay. That's also okay, but bind, I think we won't be able to write properly unless maybe we put the B elsewhere. Maybe if we say that that's the B, then maybe that's okay. And then right, and then maybe we just say that plus is actually not a function, but something like that. And then can we do the same thing without bind? Such that the second thing is a function. Well, we can, if we can do, don't know if we can. We can, maybe if we can do for here, but I don't think we can do that. And it's set B and then B to set A, right? But we can't do that. Can we do that? We can't. And maybe we need to do, if we do that, then it's still a big thing. And then the types also don't check for some reason. And then, but then those would, that somehow works, but I think this would mean like that these two B's are a different B. That's not okay. So I think we have to tuple the bind. But for our sake, let's do it with nested. Because otherwise it's going to be tricky to read and pattern match on. So let's try it like that. And then say bind blah. Yeah, and then I think we have the same result. I mean, the fact that we have the same result is just a tiny bit. Hold on. Can we do this? No. Yeah, no, I think we need to tuple it. And then position, and then return. Yeah. And then 0 we ignore. Well, okay, 0. Yeah, 0 and whatever. Okay, sounds good. And then plus like that. Is that right? No, probably not. Plus is fine. It's fine. That needs a little bit of support. Right, in that form, I think. Yeah. And then set with tuple because we want to bind those two things. Like that. B2 with B. Ooh. I'm a bit worried about this. B2 is okay, hold on. Prem S union run MA. Trying to bind that with F. Plus takes a set A and another set A and extracts the prim. Trying to match type set B2 with type set B0. As type tuple set B0, B0 set T1. Yeah, I think this is not working out for us. So maybe we will need Leibniz equality after all. Is this really saying for all B? I can bind, you have a set A and a given function from A to some B. But it needs to work with function to any B. So yeah, there is a for all there. But is it a for all here? Because if it's here, doesn't it prevent it from being used elsewhere? I mean, we did swap things here so that if you have a function from, if you have a set B and a function from B to set A, then we return a set A. That's the idea here. But what happens if we do this? Then we have trouble. So let's go back to the lightness equality here. Is there something equivalent to what is happening here? It's hard to say if it's because of what we're trying to match here is some quantification. We're trying to match a set B2. B2 is bound at 19, which is here, whereas B0 is bound at line 31, which is here. Column 49. So maybe we just need to coerce, and maybe that's okay. Since we're in Purescript 14, we can use those zero cost coercions. Let's try. And or maybe we need to use the unsafe one, because that will work for new types and stuff, but this is pretty funky coercion, I think. That B0 is the same as that B2. Run MA. Yeah. Maybe unsafe course. And I think it's really only that guy that we're trying to unsafe to import here. No, okay. So let's try that and plot bind. Okay, and boom, and boom, and probably exactly the same thing. Except with the tuples. Yeah, and yeah, I think that. No, no, bind. more bind. And more bind. Who need multi-line cursors when you can do this fast? No, I think we need more parents here rather than less. And unsafe course. Yeah. Okay, yeah. Not the best, but boom, and boom, with some extra closing parents here and that, and bind of bind, yes. So okay, so let's look again at that. Yes, so that's actually this and this. With like this, which is a bit weird, but it's fine. It just means parents here, right? Yeah, so leave it better. And so of course that with that and an extra parents and an extra parents here. Apparently, yeah, like that. Fine, like that. So I'm not sure about what's going on with the okay, so no, I'm not doing this properly. Bind of a tuple. Do you need the tuple to be in parents? You do. Okay, fine. Have it. And then here, not that. Here, of course, of this doubled with this, and that should be enough parents. No. No. Okay, and what's broken now? Ord. Ooh. Right, okay. hence the set folder, which maybe doesn't require the ord instance. The folder prime here didn't require the ord instance. Interesting. So we could manage at the top level here, but not with our not using the foldable instance. So do we have something that does something similar, like some kind of walk or something? We don't. Well, I mean, I suppose if we look at maybe even to unfoldable, could write one that just goes to list, and that's uses folder of the F. We don't have a foldable here, which is, yeah, it's the folder on the source type here. So let's look at what the implementation of folder prime looks like. And yeah, do we need to fork set? Or do we need to use another set? But hold on, folder doesn't introduce a ord requirement. So I'm wrong here, where it's not coming from folder. Checking that ord t1 implies set t1. As this is general as type set b0. B0 is bound at line 20. We're trying to bind a prim with an F. And our S, we know, should have the ord instance. But here it seems like we do have an ord as well, right? Yes. Let's try unsafe chorus. Hey, unsafe chorus doesn't work for type class instances. Is it because set.map requires some word instance? I don't know. Type variable B. Let's keep its scope. Set B to set of set A0. Yeah, unfortunately, this is a little bit beyond me. So indeed, or T1 set T1 is not as general as set B0. But the B0 you're saying is bound at line 20. So that makes me feel like expression S hat type set B0. Maybe I'm coercing at the wrong place. F I mean, presumably by running after F, that's what's going to give us the tuple. No, because we're pattern matching on the tuple here. So at this point, we're doing actual work with the set primit, the set prim. Is it that we need word on B as well here? Maybe no, that can't work. So curiously, that doesn't work. We can't match a constraint type. Not sure why. Could not match constraint type. Is there a URL for that? Yeah. Purescript could not match constraint type. Deep compiler internals. General unification error against the constraint type, for instance, blah blah blah. Trigger it. The proxy proxy class foo. Test proxy foo. And test equal proxy of type blah int. The type is just wrong to the compiler. I don't think this is clearly not a meta expansion thing. It's really that it's trying to pattern match something, hoping to return So that can't be pattern matched on. Is there a deep reason why that's the case? Could not match constraint type. Unsafe partial to drop the composition. Post was deleted. That is not cool. Oh. Could not match constraint type with constraint type issues well known. Okay. Before the type constructor. Okay, is that a thing? So then is it being about the ability to pattern match on that B1 to set A there? So we say, but that's pattern matching. I mean, that doesn't seem right. Yeah, then why? Doesn't make any sense. The error wouldn't show up on the left-hand side. Do I need parents? I don't need parents, so let's remove them. And this, yeah, when we pattern matching on this is your K1, and then apparently apparently maybe that removes our ability to pattern match on prim if we define it like that. Let's see if yeah, I think it does. It didn't without the constraint, but with the constraint it does. I mean, in theory, we need the constraint because we don't have any set B. We have a set B that actually has the OR B constraint. That doesn't work. Same constraint type. Cannot match constraint type. The higher rank have constraint, yeah. It's mainly about the type checker's internal. Its expansion is required for higher rank types with constraints. This is fine, this is not. So is this really just about me saying S prime here? Or no. This just takes a set A. So it's not that. But I think it just means that with the constraint we can't open it up anymore. We can't pattern match on it. Okay. So I think I should formulate that as a question, because there's a number of things that are obviously a little bit over my head here. One being the use of this unsafe chorus here, just to get by the for all, and now the attempt to add an OR B, and then this time a no cigar with trying to add an unsafe chorus that I can't see. I mean, I suppose we could try unsafe chorus here. Yeah, we could try removing the OR B again, and maybe unsafe chorus before. But no. I think it's trying to unify the S. So it's trying to unify the bind, and so the B, the set B that is supposed to be here, but the set B that's supposed to be here is a prim, and the S should have an ORD. So I don't know, it sounds like maybe that should work. Okay, maybe I'll just post this as a question in the Discord and see what happens. Okay. I'll log in off screen. I don't remember what my login is. Let's check. Okay. And we are good to go. And yeah, let's go in the Purescript, Discord, and help language, or help code maybe. Okay. Hi there. I'm trying to see if I can implement set monad from Haskell into Purescript. I'd like applicative instance for set. But predictably, it's a bit over my head. Okay, let's be a little bit less self-deprecating. Since set monad uses GATs, I'm a bit confused as to how to model constraints and quantification. I got two. That may be a bit too big. Oh, no, it's fine. Send longer messages with Discord Nitro. Okay. trying to, okay, I'm probably going to create a thread. Set monad. The documented code is the set monad. GADT. And below is my attempt to wiggle my way to a Purescript implementation. I'm not sure my for B makes sense, as I then had to unsafe coerce, and then I'm stuck as this line gives me this type error. Maybe in a gist would be nicer. I'll put it also in a gist. Okay, that's going to be a bit painful. Let's do this. Okay, or not. And maybe even I didn't get too far. Boom. There we go. It's a little bit nicer, I think. Okay, so that's it. We've asked for help. It's a little bit of a tricky one to solve by ourselves. So hopefully, hey, yes, yes, indeed, indeed. Thanks, Joseph. Indeed, I read a few of these posts, including this one. But I couldn't find an example with quantifications or constraints, so I'm not sure if they apply here. Okay, so hopefully this will continue offline, and then I'll come back on Saturday with some solution to this problem. A bit of a rabbit hole. If we have an applicative instance for set, then we can have our non-empty set vertex list or vertex set function. So let me write down the rabbit hole we went down here. To return non-empty set, we would like an applicative instance for set. It might be, yes, how to encode existentials with for all. I see. Okay. Right, so when I was trying to say that it was for all B's, apparently there exists a B here. Huh. So in the Haskell GADT, this is actually an existential. So are they saying the same thing also? Or they? Yeah, but we can't pass the constraint here, right? Two different. Oh yeah, you're right. There are two different A's. I see. No, but hold on. Oh. These are existentials plus type equalities. I see. Okay, I think I'm going to need to sit down with that and read more closely. Existential types are just a special case of sigma types. So in the end, yeah, there is this weird thing, and then I think this show dictionary is a reification of the other constraint, I think. Okay, I should realize I'm not showing my screen. Let me show my screen, and oh, I'm typing right in a place that doesn't display on screen. So let's be a little bit friendlier here. So I'm getting some good advice here, including some Stack Overflow posts about, and some schooling about what GLTs really are, and the fact that this set A set B, set B, like the A doesn't have anything to do with that A. So anyway, to quickly code up an applicative instance for a set. Let's laugh a bit about that. Okay. Okay, awesome. Thanks a ton, Nate and Joseph. Really appreciate the help here. I'll get back to it on Saturday, and maybe I'll dig into this and try and work out really what JDTs are under the hood from a compiler perspective. So that's it for me. Thanks a lot for watching, and see you later. Bye bye.